Hello. Good morning. It's awesome to be here again. And before we start, I have a quick question for you. So this talk is about frameworks, ergonomics, and toolings. So let's do an exercise first. We are going to go on a race. And you can pick one tool or not use a tool at all. You don't need to raise your hands or stuff like that. Just which one would you pick? Think that for a second. Everybody chose? Yeah? So the race is actually going to happen here. So that's the point. The point I'm trying to make is that each kind of tool, or code in this case, has its own kind of success. You might pick one that's the best one for it. You might decide to go all in on yourself. But what success looks like depends much more about which context you're going to use things and how you're going to use things. So this is actually a talk about trade-offs. Trade-offs on productivity, trade-offs on abstractions, on syntax, efficiency, on tooling, and on vibes. Yeah, sure, why not? And yeah, so now we're ready to start. So as Daniel said, I'm Atila, and you can find me on pretty much any social media. I'm too often online. And I have some handy redirects and shortcuts for you. So it's just atila.io, and you can put whatever social media and you can find me. I am a Google developer expert for web technologies. I am part of the Solid team. And I'm also a developer at the database, serverless Postgres platform called Neon. So yeah, let's get started. First, we're going to build a web app. And this is how the web app looks, right? So this is happens on pretty much every framework. A nice idea that we had a few years ago is to divide our UIs into components, right? So then we can encapsulate, we can make logic reusable, we can share that logic, and we can use the components in a lot more places. And then what happens is that these components, because they're part of the same app, naturally they have shared state or data in this case. So let's say, for example, I have one component that has that me endpoint, which grabs the stuff from the data from a user profile. And I also have another one that takes the ID of the user and grabs their projects. And another component takes the data from the user, like last time the user changed something or updated something, and the data from the projects, and build up the stats. So the way that our app looks like is we want to basically fetch both of those endpoints and propagate those changes to all the consumers, right? And the first gut reaction, like when you're talking about React, or for example, or SolidJS, it's, okay, we're going to hoist that, and we're going to make a provider that's going to share the data through all of them. So then we fetch only once, and every time the data changes, things are going to update, right? Everything works. But there's a but. And just for a quick survey, who here sees something wrong with that previous approach? Can I go back? No, I can't go back. Who here sees something wrong with that approach of having one context provider sharing the data for both of them? Yeah, a few of it. So that's the dangers that I'm trying to point out in this talk as well, is about how a tool should behave. So what happens here is we have these three components, right? And each of these components, they have a specific piece of data. One component gets the user, the other component gets the projects, and another component is going to get a mix of those. So that's kind of a derived state component. The API, then one of the APIs are going to get updated. So let's say, I don't know, you got a new project. And then the context is going to update because one of the data dependencies got updated. Context updates. But because the context updates, what happened is that everything under the context, all the children are going to re-render. And that means that there's going to be one component that's going to re-render for no good reason. Nothing's going to happen. And then, yeah, I know what you're thinking. You split the context, you have single-purpose rule, yeah, and oh, yeah, I run it twice just to be safe. So for that one, actually, this is like not specific to React, but this is like how we do things in React. And actually, Vitor has a talk coming. I think he's the last. You're the last talk, right? The last talk of the day is going to talk about React compiler, on how React actually optimized or abstracted all of this to you. So make sure to stay on his talk. He's going to go through this, like the pain points of this, how to leverage the compiler, and how React from 19 on is actually fixing this for you, so you don't need to know exactly what you need to do to prevent those issues, but most importantly, what you cannot do to cause those issues even without the compiler. But the other components, other frameworks, instead of the compiler, they went for something else. They went for signals, which is a different kind of heuristic on how to render stuff on the web. And it would not be a talk from me if I wasn't take a time to talk about signals, because as Daniel pointed out, I'm part of the DX team on Solid, and Solid is the framework for signals. Like, it's a whole rendering library created around signals, and we really are very bullish about it. So let's talk a little bit about how it impacts the way we think about the user experience and how we think about rendering stuff on the web. So we have essentially two different architectures, or three. So we have pull, push, and then we also have a mix of them. So let's see the differences between those things. So for pull, you have a data source and you have a component. And the pull means that the data source doesn't know about the component, and the component needs to then pull those updates from the data. So the component doesn't know if the data is updated or not, and just have, do you have updates? No. Now, do you have updates? No. Now, do you have updates? And then the data, and then eventually there will be an update, and the data is going to give. But the data itself doesn't know where it should go, and then that's why React, as being a pull system, it needs to then have that tear down and re-render effect. So that's why the re-renders are very important for React, and we cannot like ditch the re-renders, but we do want to have them happen only when we need them to. Then you also have the push architecture, where instead of the component grabbing the data from the source is going to stuff the data inside the component. And that means the data knows exactly where it needs to go. The process of having the data happens only when there's an update, but that also has some trade-offs, because the data source doesn't know if the component's ready to receive that data. And that can cause, if the data is too frequent for the component to handle, that causes something we call back pressure. And this can cause, in light scenarios, that you lose some packages. So pieces of data get lost, and then you get like your app jumping through states and stuff like that. And in worst case scenarios, you crash your stuff. And then we have push then pull, which is what we do with signals, where essentially you have the component and the data source, and then the data source is going to notify the component, I updated, time for you to run your stuff again. And then the component is going to fetch the update when it's ready. So it is a mix of them, because there is a subscription model where the data says, I know who needs me, and I need to tell them to re-execute. And then they re-execute only that particular part of the data that got updated. OK, rendering is done. You know, like the main heuristics of rendering stuff on the browser, and now you can make your choice. But let's move on to like more complicated scenarios. The web is actually a fetch fest. There's fetches everywhere. Like right now, that example that I did had two components fetching stuff, but in reality, you have fetches every single place, which That's why we're talking so much about asynchronous data, suspense, server components, and stuff like that, because all the data is coming from a different kind of source. And when you're building an app, a real-world app, you need to handle that fetching in a way that's optimal. You don't want every single component fetching their data any given time and like not minding about all the surroundings and updating the app in their own time, because that's what we had with like jQuery and in the early 2000s, and that's not optimal. That can be fast, imperatively, but then that means we need to deal with a lot of other stuff, namely the router. So what frameworks do now is they create a router for us. They create the whole logic and architecture for the router. And that means they do bundling, tree shaking, chunks, asset loading, preloading, prefetching, URLs, segment URLs, params, search params, rendering, serializing, serving, streaming, caching, updating, securing. And then they connect, they fetch, they parallelize, and they duplicate. So that's the kind of things we need to do if we don't use a tool for our router. And that's the kind of thing we were stuck doing before. And some of those things are, and if we do that by ourselves, we end up tired, essentially. That's like our whole job becomes maintaining those things, especially because some of them are particularly tricky to do, like tree shaking. Like removing the code, especially now that we have this isomorphic code that, remember on Josh's talk, he was talking about sharing data validation between client and server. So that's possible because of isomorphic code. You have one code base, and then you have a bundler that's going to split the code and say this code goes to the server, this code goes to the client. And your tool knows that for you. That is possible because of tree shaking, or more specifically, code removal. So our bundler knows, okay, this has this use server, and then we put it there. This use client goes over there, and so on. It's particularly hard to do. Serializing is very, very tricky because you need to send a lot of data through the wire. It depends, especially if you put up streaming with it and caching, and making sure that all this data coming through the wire is not blocking each other, because the one thing that you don't want in your consumer app is having a lot of chain reactions, and then where resource number 2 is blocked by number 1, and so on. So let's talk about tree shaking first. So this is the trickiest thing you can do. Like if you have a tree shaking system and you want to see how aggressive it is or how safe it is, you can try to do like this. This is we call closure extraction. It's the trickiest thing to do. I think most code removal tools are going to bail on this, and I'm going to tell you, no, you cannot do this kind of crap, because what the tree shaking and the code removal tool, code extraction tool is going to do is going to turn your whole code into a tree, like an AST, and basically realize, okay, this is used only on the server, this is used on the client. But what we're doing here is we're tricking, because we are declaring a server function inside a client function. And this essentially is going to fool your AST by saying a server data is needed by the client, so it needs to be on the client bundle, otherwise it's going to break. And then that's how you end up leaking your database password. So that's something to avoid, and like more aggressive tools are going to then not build your code and let you know with a nice error message. But there are tools in the past that because they believe in the resilience of the code, they would just try to execute anyway, and that would happen. You end up mixing, you would end up with some server-only stuff on the client. Yeah, essentially this. So the count and the another one would end up in your client bundle, even they are being completely outside of your of what you wanted to do. Okay, so the next tricky things is serialization, caching, streaming, and security for the router. So let's talk about the one that I'm more familiar with. Like, that's what happens in your server. So on an isomorphic framework, you have all these server functions. These server functions, to avoid a bunch of requests coming out of your system and overloading an external API with duplicated requests, what we do is we create an ID for them. And then when two components fire the same fetch request, they have the same ID, so we have a little caching that's like basically the duplication mechanism for requests. And that's going to say, okay, all these two are going out on a very similar time interval, so we're going to fire only one, and they're going to use the same response. That timing is about, like, it's just essential for one round trip to the server, so it's more or less 5 seconds. And then you have an awesome database, like, for example, a serverless Postgres, and that's going to then return you the data. Once that happens, it goes through the serializer. So the serializer is going to take all that data and is going to turn it into a string, essentially. So it turns your objects into a string, your arrays into strings, things to make it easier to parse. And in our case, in SolidStart, we decided that our serializer will also deduplicate the resources now, because we want to also save the bandwidth between the server and the client. So this, we have essentially, like, if the guy who wrote this hear what I'm about to say, he's going to come up here and not let me do it, but essentially like a centralized store that's going to store some references for each resource, and then return only one response for each one. And then this goes to the RPC, and that crosses the serialization boundary. So as I said, this is like a SolidStart code. Serializers, they behave slightly different. Especially the deduplication of resources, I think, is only us doing it right now. But I know that Svelte has also a great serializer. They can also do, like, I think they can do async iterators like we do. And I think it's also coming to React, or already came in React 19. I'm not entirely sure. Then the last part for the router, and another one of the very tricky one, especially because now it's dealing with both the server code and the client code, is the parallelization. So let's take, for example, in this situation, this JSX looks weird if you're a React developer. That's because it's solid code, but doesn't matter in this case. Like, it kind of behaves the same way in all the frameworks. So you declare a server action, which is basically a server function that's going to run as a response to a form submission. And then you define the method to be a post. What happens, though, is that we throw the redirect on the server. And we are throwing that because we want to immediately stop the execution. And by doing that, you also want to then revalidate the user, because if they're logging out, I don't want them to have sensible data on and not logged in experience. This is all great, and this actually unlocks a very nice feature if you put it together with something called preloading. So the way we load data in Solid is essentially with a create async, and that just creates an asynchronous piece of data that's going to receive a promise, and then it's going to turn that into a synchronous signal for your UI. What we do then is, when we export a route, which is kind of common as well in Next.js, you can export that. In 10-stack start, you do that. Pretty sure in Remix, you also do something like that. And you can define then, okay, this is the load thing. This is the kind of data that my route needs. And that's going to allow our router, both in the server and on the client, to know the kind of data they want to prefetch. So if you put that together, if I know on the server that I'm redirecting to a route, and my server knows the data that this route needs, it means that when the server is returning the response of the redirect, it can also already send the data for the next route. So this is basically saving your user 2 round trips. It's making your app much more snappier. And this is what we called a single flight. At this point, it's only on Solid, but it's also coming on 10-stack start. pretty soon. And then there's the cherry on top, which is managing cross-route state, because now that we have a server, we don't know which route the user is going to enter, which means that routes are also a state management tool, because we have those search params, which, as per the HTTP stack, is HTTP spec. Those are just strings. So we need to validate them. And then it comes to this input validation. So let's say, for example, and Josh mentioned Zod in the past, in his talk. So this is actually using Zod. And this code is from the 10-stack router, which there is a talk from Joanna. I think it's right after lunch. And she's going to dive deeper into this. But what 10-stack route is doing now, it's allowing Zod to, on runtime, validate your search params. So you can say, OK, so my user has a UID. And if it's not, I'm going to catch it, and I'm going to pass a value of guest to it. And then whenever my route's loading, it parses that with Zod. So it's going to make sure that my search params, my URL, is type safe. So this saves you a lot of work in terms of validating things for each component and so on. So yeah, as I mentioned, this is 10-stack router. It works for React, and it works for Solid as well, actually. So in the end, the way you're going to use it would be like you create the route, like in the previous slide, and then in your component, you're going to use that route you just created, and you're going to bring the search, and that's going to be type safe on runtime. And that also, and because the router is all type safe, you can create then this navigate hook, and you can pass the route it's coming from whenever the route is coming to, so it already knows all the data that's already in place when you're redirecting your user. So then you can have logic like this, for example. So if I don't have a user, I navigate them to a guest pay experience. If I have the user, I navigate them to a profile page. Yeah. And yeah, so let me show you all of this playing together now. Like as I mentioned, I work at a database company. So this is something I've been working on for a while. Let me just make it a little bit bigger. And here I have my 10-stack app, which is a regular, I need to delete this, which is a regular 10-stack 10-stack app. Nothing too much special. I do have like some stuff over here, like regular routes declared and the route generation and so on. And the nice thing that we have is we have in the define config, I'm passing something called a Postgres plugin. And this Postgres plugin has the schema JSON. And remember that thing that Josh mentioned about the Swagger or Open API or stuff like that, where you can define schema for JSON files. So this schema allows me to make sure that I can only type the right types for the keys that I want. So if I put something else, it's going to tell me, no, type needs to be a Boolean for non-nullable. And so, like, just to show you this, let's go name and JNation for creating my schema. And it needs a type, and it's going to be text. Cool. And yeah, awesome. So what this is going to do is, with this little plugin, because I have everything type safe and so on, and because I already know what my user wants, and I have control about what my backend is going to be, whenever I run the dev server, this Postgres plugin is going to check if I already have a database. If I don't have a database, it's going to create one for me. And boom, it created one for me, and I can claim it to my account if I already have an account, which in case I do. And if I created the account, you're going to see that then I already have all the schema that I generated on a JSON in a Postgres database. So this is the kind of stuff to exemplify what I think about the JSX and how we put all of that together, because that kind of puts, like, we have the sorry, that was a huge gong. So tools are supposed to make you write good code easy, which means like instantiating a database or making sure you can prefetch stuff and so on. And they're also should make you writing bad code hard in terms of the code putting like server functions inside a closure and so on. That's going to allow you to leak your variables. So that's the whole point about picking ergonomics, using the tools for having better ergonomics. You don't want to like create your own router and stuff like that. But you do want to understand how each tool works to pick the right one, so you don't end up with a super bike racing a camel on the desert. So that's what I had for you. Thanks a lot for coming, and let's go to a coffee break.